said, Mr. Gale, you can go home. We have it under control. So that is so cool. They got it all under control. Good to see you guys. It's so much better than, I mean, I did appreciate getting to see some of the students that I've um, had in the past or that I have now, but I didn't get a chance to talk to them. As soon as they got done, they split. So I can imagine. Hey, Kamaya, missed you, and you and Naya missed you as well. I haven't seen a lot of work being done this week. I imagine you guys had hardly any live teachers, did you? Anybody have any live teachers at all? Anybody have any? Thought everybody took off. Yeah, you didn't have any live teachers. Yep. So that was hard. I know. And I missed you guys. I was so bored. Oh my gosh, I was so bored. Yeah, okay. Well, that's not as bad as some people had. All right, so you guys, there is a link here that I want you to get into. This is what it looks like. Okay, right here. And if you click on this right here, I'm going to give you 5 minutes to do this part right here. You should be able to have a link here that says 211 pretest. So pretest, remember, are bonus points. Doesn't matter what grade you get on it, just a before and after. See what you know before, and then hopefully what you know after will even be better. Hey, Shayana, Shayana. I've been out of practice, Shayana. Sorry about that. So get it in there. Get to this first one. Give you 5 minutes, 158, 10 questions, and then just post what your final grade was 3 out of 10, 8 out of 10, whatever. Remember, you get 10 points regardless, right? So go ahead and do that. I know there's not a lot of people because they weren't expecting me. So I'm glad you guys are able to see that I'm back. And then we're going to be working on this assignment as we go. So you have this assignment as well. I'm going to pull people out um, in finishing this up because it talks about how to balance equations. I'll go over a couple of the balancing equations, but we'll do a breakout room and go over more in depth. Okay. I'm going to put this on pause here while we wait. That's okay. Just keep working on that, and I will go over the assignments here. Okay. So this week, okay, we are talking about types of reactions, and you will be given a chemical equation and you'll be able to identify it. There are 5 types: synthesis, decomposition, single replacement, double replacement, and combustion. All right, and you got, again, this is one of those things where you need to have some notes, okay? But there is a pattern to them, and we're going to use Fred and Wilma from the Flintstones to help us. But before we do that, while we're waiting for people to catch up with us, we're going to do some things here. Remember, in the chemical equation, all right, and I'm going to escape this because I cannot do this, and you're going to do the same thing I'm doing. So reactants are the ones that start us off, right? Right, and the products are what we end up with. So what goes in comes out differently. So H2 and O2 gives us H2O. That's totally different than it was in the beginning. And then yield, oops, where's my yield? I got to get it. There we go. Yield fits there. So reactants yield or produce a product. So two become one. You can see that, and they react to each other because if they didn't react to each other, they'd be the same. It'd be H2 plus O2 gives you H2 plus O2. But gas, hydrogen gas is flammable. Oxygen you can breathe. Water you can't breathe, and it doesn't burn. So it's something we need for life, right? Okay. So here is some some information for you. I'm going to get this so you can see it better. So I'll turn my camera off here. So the reactants are the part that we start with. Okay, so on the left side, it's the substance that participate in the chemical reaction, the left side. The reactants are the raw material that react. So you can see from this is chlorine gas, two green ones, and this is hydrogen gas. You notice that they are all separate. They're not doing anything, so that's why there's a plus between them. Now, the reaction or the product, it looks a little different. So the reactants are the chemical reactants are transformed into the product HCl and H2. Still green and white, but notice this is my HCl, right? Hydrogen, white, combines with a chlorine, green, and there's some H2 left over, but that's my product. Okay, they chemically combine, totally different. It's no longer two gases. It's a gas that it can burn things. It's a hydrochloric acid. When you add it to water, it'll become this battery acid. Now, when we balance chemical equations, that's what we were working on last week. We had to use the coefficients. We could change the coefficient. The coefficient is the number in front of the chemical formula, right? Now, we don't need to put the 1 in, but I do just in case, right? We cannot change the subscript, which is the number of atoms in a molecule. We cannot change those. We can change the coefficients when we're balancing equations. And we balance the equations because what goes in has to come out, right? So chemical reaction is described as a chemical equation, right? The substances that are involved in the reaction, right? The reactants are on the left side, and the final compounds are the products, separated by an arrow or a yield sign. This is a chemical equation. This is a chemical formula right here, CH3, C3H6OH. That's not a chemical equation. An equation has pluses and arrows and things like that. All right, so let's take a look at this drag and drop. Just to give you an example. All right, so CaCO is a reactant. The CO2 is a reactant. When we combine those together, we get a product, CaCO3. So you can do the same thing down here. You can do the same thing down here. All right. Tell me if I need to slow down. Have you caught up with me? Let me know. Okay. If you want me to slow down, this is the time to do it. I think I got 12 people in here. Did I say hello to everybody? I think I did. I think I did. Okay. Okay. Guys are really quiet today. All right. So in the breakout room, we'll be going over this part and this part. Okay. So let us take a look at how to balance equations. Let's do this one, how we do it here. Okay. So this is balancing equation using kind of examples or symbols and as the chemical equation, but then we can also, let's put the this as, start with 1 in each one of these, 1, 1, and 1. So I've got 1 sulfur atom, 1 oxygen molecule, and 1 SO3 compound. Now notice from my arrows, okay, sulfur I have 1, and sulfur I have 1 here. My oxygen on the reactant side, I have 2. My oxygen on this side has 3. So we are unbalanced here, okay? So what we have to do, we're gonna try this. So we have, so we can get the same amount here. Now this is a little unusual in that because it's got 3 and 2, this one I would suggest that you go ahead and add one more of these. Now I have a 2 here, right? Now I've got 6 oxygen and 2 sulfur. So now because it's heavy on the sulfur side, okay, sulfur is way heavier on this side. I'm going to add another sulfur on the other side. So I'm going to do this. I'm going to put another sulfur over here. Now those are balanced, 2 green circles, 2 sulfurs, but not enough oxygen on this side. I have 6 on this side. All right, so let me ask a poll question. Start a poll. What number, this is slide number 15, how many oxygen? Remember, it comes in two O2s, so it comes in a pair. So type in your number, how many oxygens for this particular, so I need to change the oxygen to some number to get to me to 6. What number do I need to get me to 6? Remember, it's 2 times some number gives me 6. I want 6. What number am I going to put in there? All right. Thanks, Madison. Thanks, Jeremy. Thanks, Mariana. Thanks, Joe. Thanks, Joey. You're right. You want to put a 3 here, okay? 3 times 2 is 6 because we do that 3 times 2 here. Okay, so if we think about it, oops, I'm doing too many here. Come on, stop. All right, so now I have three pairs of 6 to make 6, 2 sulfurs, 6. So here is a balanced equation. So what goes in comes out. That's the law of conservation of mass. Conservation of mass says I have to have the same number of atoms going in as I go out, and they also have to be the same kind. They could be rearranged, but they have to be the same kind. All right. So we'll go over that again here. We'll go over some more balancing equations. So here is where we are today, the types of chemical reactions. So we're going to talk about the chemical reaction of synthesis and decomposition. We'll be going over these two tomorrow, and then this one the next day with the review. Okay, so this is the kind of stuff that doesn't stick in your brain readily unless you've been taking notes and so forth. Something you can refer to. Okay, thanks for you guys for participating in that poll. If you are doing this, there is me talking about the synthesis and combination. So if you miss my recording, it's also in the notes. Okay, so a synthesis reaction is 2 or more reactants. Remember, the reactants are on this side. The product is on this side. So 2 or more, 2 plus, I'm going to be 2 plus, gives you 1. We always know we get just 1 at the end. 1 product, 1 P, 1 product. 2 or more R's gives us 1 product. So here is an example of a synthesis. They also call it a combination reaction when you're combining them. Synthesis also means to combine, right? So we don't have to worry about the coefficients in here, but I know this is A, this is B, 2 separate things because of the plus in between. And I get one thing here. Now, again, we don't have to worry about the coefficient. The 2 does not mean it because I could put a 2 or a 3 or any coefficient. I get one thing. This just says I have 2 of those of the same thing. Okay. So 1 plus 1 gives me 2, but you're multiplied, you're getting them combined. All right. So think about it. Fred and Wilma. Fred and Wilma are separate in the beginning. They react, and when they react to each other, they become a couple. All right. So they could become a couple. So they became an item, Fred and Wilma Flintstone. So they got the name there. So that's how I think about synthesis or combination reaction. This couple, they were not a couple in the beginning, but later on during the reaction, they did become a couple. So here's some examples of synthesis or combination. This needs to be balanced, okay? So, but it is A plus B equals AB, and you can see that the KCl is the same thing here, except for the K, you got 1, and then I got 1 on this side. Cl, I have 2 on this side and 1 on that side, right? So I'm going to have to change this to a 2. This will make this go to 2 because it's lighter. Okay, just like a teeter-totter, right? If you have a person that's pulling you down on this side, right? I've got to put more weight on this side. So I added another Cl to this. I had 2 Cl's here, and I have a Cl. Now it's balanced almost, except for now I've got too many K's. So I'm going to make this go to a K, 2 K's. This stays a 1, 2, 1, 2. Now it's 2, 2, 2, 2, perfectly balanced. And again, like I said, you can see that 2, A and B, make 1, AB, putting them together. Now the balancing part we have to do, but we have to look at the chemical reaction and see what that looks like. Remember, Fred and Wilma become a couple. That's a synthesis reaction. All right, so let's do this poll question. A, B, or C. This is, excuse me. This is slide 25. 25. Okay, which is the synthesis in this particular equation? Synthesis, A, B, or C. Thanks for voting, because this will tell me if I'm making any dent in your brain, because this is hard work. You guys are working. It's a 6th hour. You're going, oh, I'm tired. Mr. Gale, you're just boring me to death. Oh, no, I hope not. Thanks, Mariana. Thanks, Rihanna. Anybody else? Victoria, Tanisha, Joey, Kamaya. Thanks so much. Bradley. Thanks, Joey. Anybody else? All right. Madison, thank you. All right. And Jeremy, thank you. We got a split decision here. A or B, it seems like. And thanks, Jasmine. 7 out of 14, half of the class. So most of you think it is this one. Where are you? All right, where are you? Okay, there we go. It's letter B. Remember, if you take a look at this, this is A. Even though it's CaO, it's one thing. The plus tells me it's one thing separating B, and then I get the AB. So we got a combination of Ca and O and H, so the H is in there. That's A plus B equals C. This looks like something else. This looks like, so A and B still have another A and B, okay? Or C and D or something like that. So that's not it. Okay, so if you take a look at this slide, turn on the pen here. So if I have this as A, atoms or molecules, okay, so that's CaO, and then the H2O, see, those are molecules, right? Those are molecules. And then I get that CaOH. It's a compound, right? So two things become one thing, and you can see it's combined. There's no pluses on there, okay, but there is a plus between those, right? Now let's take a look at what we call, this is our synthesis reaction, right? Let's take a look at the opposite of a synthesis reaction. This is called a decomposition reaction, where one reactant, one becomes two or more products. So it's the opposite. Remember, the other one was two becomes one. Here is one becomes two. One becomes two. This is one compound becomes two or more products. Okay, H2O, that's my AB. Separate it, you get H and O. So this is water, and then you break it apart using electrolysis. That means putting electricity through the water, and you get hydrogen gas, which causes flames, and oxygen, which you breathe, right? Okay. All right. So you can open your mouth and breathe in some oxygen through your nose and so forth. And that's totally different than drinking water. You couldn't breathe that unless you're a fish. And that's because there's oxygen in the water, but we can't get that out because we don't have that special stuff. So here is Fred and Wilma again. They are a couple, and now they split up. Okay, maybe they're seeing other people. I don't know, but they've split up or they're mad at each other. Could be that because Fred always loves Wilma, but they sometimes don't get along with one another. So here is some more examples of decomposition reactions. We've got an A, B, and we get A plus B. Still needs to be balanced, okay? We'll talk about this at the breakout. AG and AgBr, so silver bromide becomes silver plus bromine. Here is carbonic acid becomes carbon dioxide and H2O. So again, remember, even though it doesn't look, it looks like one thing, two things, right? Right. Hey, Oz, did you just get here? Late. Oh man, you're gonna have to watch the video here. Okay, so remember decomposition, we start up here. This is our reactant on the left-hand side, okay, on the left. And now we get A plus B, okay, just the opposite direction. So if you look at what we had before, okay, A plus B gives us a compound. So this is the reactant, and this is the product. And on this side, this is the reactant, and this is the product. Breaking it down, decomposition, breaking it down. And you've seen that. You throw an apple outside, and it's not no longer going to be an apple very long because it'll break down into the dirt. Other animals will eat it as well. But banana peels, not too many animals like to eat banana peels. Okay, so let's take a look at this. Okay, so let's escape this a second. All right, in the decomposition, okay, of this, in this decomposition reaction, let's start a poll. This is slide 33. Which of those, which is a reactant? Okay, which is the reactant on this one? Which is the reactant in slide 33? Type in the response. Which one is the reactant here? All right, decomposition. 1 goes to 2, right? 1 goes to 2 plus 3. So what is the reactant in this? Type that in there for me. Is it ZNO, CO2, or ZnCO3? Thanks, Shayana. Thank you much. Anybody else? Thanks, Mariana. Anybody else? Got two, got two. All right, thanks, Joey. Remember, decomposition starts with a big thing and into 2 little things. So what is the biggest thing on there? What is the biggest thing on there? So we're looking at this right here. We're looking at one of these things. You're writing either this, this, or this. ZnCO3, ZnO, or CO2. All right. So let me help you out here. We got it. Okay. So, all right. So ZnCO3 is the part that's going to be broken down into ZNO plus CO2. If you can see that, we've got those all combined, ZnCO3. This doesn't, Zn doesn't have CO in it, so it can't be the biggest thing. And this has CO2, doesn't have the Zn. So you've got to put all those together in order for this to work. Oh, too far. All right, so that's the decomposition. All right, so this one, I'm sorry, this one I want to make into a synthesis. I forgot to type this in, synthesis. Okay, and this one is A plus B equals AB. All right, so let's get this right, synthesis. Okay, so let us put the arrows here. We know it's got a plus here. Nope, I'm sorry, it's got a plus on this side. So 2 things give me 1. Okay, so what's going to be on this? So let's start a poll. This is 36. What is going to be on the product side? Product. Which is the product for this one? All right, type in your response. Which is going to be the product for this one? We're running out of time, ladies and gentlemen. Got one more slide to go, and we are done. Okay, what is the product? So 2 things become 1. So I'm looking for the 1. Which is the 1 on here? Which is the one thing when we combine them together to make one thing? Remember, they're reverses of each other. So, all right, it's got a couple of votes in there. Thanks, Mariana. Thanks, Shayana. Good job, Jasmine. You too, Shayana. Okay, we're looking for the most complicated one where 2 become 1. We're looking for the 1. Hey, Austin, I didn't see you come in. I know I saw Oz said hello. Anybody else did I miss? I think I got everybody. All right, so this one is the combination of this and this, right? ZNO plus CO2 gives me ZnCO3. So you see you have ZNO. This has Zn and C and O's. Okay, so that is a synthesis. So you can see, comparing decomposition, this is the decomposition starting with 1, breaking into 2, starting with 2 and combining to 1. So break apart, combine. Okay, so last question on this one. I'm going to give you the letters here. A, B, C, and D. All right, this is slide 36. How was this slide 36? I was on slide 36. All right, start a poll. All right, so which is the decomposition? Decomposition. There are two of them in there, so you can pick two. All right, A, B, C, or D. There are two of them in there, A, B, C, or D. Which one are decomposition? One becomes two. One becomes two. Thanks, Jeremy. Thanks, Bradley. Thanks, Mariana. One becomes two. Thanks, Jeremy. Which of those shows one thing becoming two? All right. Thanks, Oz. Thanks, Madison. Who else did I get in here? Thanks, Jasmine and Bradley. One becomes two. All right. So if you said B or C, you are correct. B or C is decomposition. Okay. So you have a choice. Okay. Finish up these slides. Right. Finish up these slides. Okay. Now I have for you guys here. Oh, what happened to my slides here? Okay. Oh, no wonder I'm in the student version here. Probably was fixing these up for you guys. Oops. I want to keep this. All right. Okay. So let me go over here. I was supposed to be on this one. Okay. So for today, okay. So here is our class, and these are the people that did not get quiz W2 assignment 1 done. All right, so you have a choice. I'm going to be talking to people here about balancing equations. All right, I'm going to pull those into breakout room. If you want to get into the breakout room and if your name is not on this list, let me know. Okay, most likely I'm assuming that because people were without help last week that you could use some help on balancing equations. So, and I'm here for you. That's what we're going to do in the breakout room. All right, so I'm going to pause the recording. All right, ladies and gentlemen, I'm going to let you go. Let me clear out the chat and say goodbye. Let me go I'll unlock the fly. All right. I forgot to lock that. See you guys. Have a good one. Talk to you tomorrow. Thanks so much. Hey, you too. I appreciate you saying that. It's already been a good day because you guys are here. All right. Goodbye, guys.